Hello everyone, I'm Abhishek and he I think Welly introduced me. So yeah, will not waste more of our time and will directly jump into the topic. And before we go into the topic, I would uh, tell you a few things that how I like to take the session and how we will go about this particular session. So one thing is that in the session, if you find anything, like if you have any doubts or anything, you can just raise your hand either. Okay, and try to unmute you. Okay, in that case, or you can do is uh, you can just write in the chat, and that would be more than enough as well. Okay. Uh, right. Regarding the doubts, I won't be taking your doubts at all the instances. Okay, just figuring the camera. Yeah, so I won't be taking your doubts at every regular instance. Once I have completed a particular topic, I would then take your doubts on after that. Cool. So that is how we'll go about in this session. And anything, I think you are allowed to unmute as well. So yeah, we can do that, or you can write in the chat in the chat, and I would be regularly looking onto that. Cool. So okay, then let me share my screen, and you can let me know in the chat if that is visible. Cool then guys, you can see I have opened the chat in the side, so you can chat me anytime and I would uh, take your doubts in that. Cool. And in order to hide this, what I can do is I can turn off my camera and yeah. Cool then, let's start. I hope some of you might be having some experience with statistics and data science to be specific. So before we start, I would just like to get an introduction from your side as well, like which year you are in, which what is your majors in. Okay, if you are working for a company, okay, how many year of experience you might have. So all those things, it would be great if you can share in the chat, and then I would get an idea of how the audience we have today. I can see more than 100 people's. Okay, now a one-liner definition, if I have to give you for the statistics, it would be statistics give us the methods of gaining knowledge from the data, and that's it. Nothing else, nothing more than that, and nothing less than that. It simply provides us and give us the methods to gain the knowledge from the data. So we have the data, like the data now, the data can be of in any form, right? So let me go to this presentation. Yeah. So now the data can be in of any form, like data can be in the form of, let's say it can be form of images. Data can be in the form of text. There can be text document as well. Okay. Data can be in other forms, like data can be in the form of video as well. So data can be in the form of many ways. So once we get the data, we have to process it. Okay. So I'll tell you what is the pipeline of data science. So firstly, what we get is we get the data, okay, from some source, okay, either through web scraping or through some external sources. Okay, so there can be web scraping. I'm sorry, I'm deviating from topic a bit. Just hold on for a couple of minutes. Once I'll tell you what the importance of the data is and what value the statistics brings into the data science. That is what I need to explain you. Okay, so this is what I'm talking about is a data science pipeline. Any data science project you pick up, this would be the process that it has followed. So we get the data from either web scraping, or we get the data from in the form of CSV file, either from the stakeholders or some client or some other people who want to do this a particular task from you, right? So we can get the data in the form of web scraping or CSV, in the form of CSV files, or in the form of Excel or anything. We get the data ultimately. Now this data that we are getting is in the form of raw data. Okay, this data is not the completely pure data or completely processed data, right? What do you mean by it is not processed data? Like it can contain some missing values. In data science we call them NaN values, right? There can be some missing values. Let's say I took a survey. Okay, let's say analytics vidya itself, they took a survey uh, of how many students know data science. Okay, and there are few columns like name, phone number. Okay? Then there can be column of year of experience. Okay, now let's say in the backend, all of them are strings. Okay, all of them are they are expecting that the people will insert name, phone number, and year of experience as in terms of string. Okay, they are taking the input at the string, but you know the people are not that very straight, right? Sometimes you get the data in so much different form that you might not have expected that, right? So what you can get is you can get the data. Obviously the name can be like, sometimes the name can be, let's say some people is filling, let's say there is a spam, some spam person or some unknown user is filling the data, so he can fill 0 in the terms of name. In the phone number he can fill -1, or because if the data is now 0 is acceptable, because you are taking the data in the form of string, right? So 0 is a string, -1 is also a string. Okay, they both are string, and the year of experience, let's say he has written none. Okay, now again this none is also a string, but you see the problem arises when you have this data of one type, other type of data can be Anand, and then phone number can be, let's say, a genuine phone number of 10 digits. A year of experience can be, let's say, 2. Okay, so this is what we call as a genuine data. This is what we call as a genuine data, and this is what we call as a spam data, or not the data which is of no use for us, right? So in this case, you have to remove data of such type, right? So such type of data in the time of web scraping or in the time of CSV file, because this is the Google form. Let's say this is a Google form that they are filling. Now, if you have made any time Google form in your life, you must have seen the responses of the Google form are collected in the form of Excel sheet, or like a Google spreadsheet, I think, right? And now the Google spreadsheet, it can be downloaded in the form of few forms. It can be downloaded. Other first one is, I think, PDF. Other is Excel, or you can download it in the form of CSV. Okay, so let's say you have downloaded this complete data in the form of CSV. Now you have got the CSV file where the name is written as 0, phone number is -1 in the CSV file. This is a CSV file, Excel kind of thing, right? So there it is written 0 and -1 and none. Okay, but other entries are very good, right? The other entries are very genuine, and in the middle you have such kind of rows. Now what you will do with that data, right? So now you have to remove such type of data. You have to process pre-processing. The term that is called in data science is called pre-processing. So pre-processing of the data is the step you have to do next. So once you have collected the data, then you have to do the pre-processing of the data. So pre-processing of the data is done. Now once you have done the pre-processing of the data, what I generally prefer is going for the visualization of the data. Like you can visualize the data. Let's visualize using, I think, matplotlib, or you can use Seaborn or some other library. If you know, you can use that, or like, let's say, Tableau or Power BI, if you want to use, you can use that as well. So once you are done with that, you have visualized the data, then you need to, on the basis of the visualization, you have to select what algorithm you are using or what model you are going for, right? Then you have to choose between that, what model you are using. So let's say you then the next step would be model selection or model implementation. Once you are done with the model, uh, once you are done with the model selection part, then the term is the final part is comes is documentation, or documenting the complete data, documenting the results that you have got, insights you have got. Because in terms of model, you have to, let's say you have made some prediction. Okay, let's say you have made some prediction, or some result you have taken out, let's say you are getting some kind of error in your prediction. Okay, so all those things you have to mention down in a document so that you can submit it to the stakeholders, either who have given you data or who has asked you to do the data science, like, complete thing, right? So that is the pipeline of any data science project. So where statistics fits into this picture. So when you are going for visualization, and so just after the pre-processing step, when you are going for a visualization, you would require data science, or you would require statistics. The complete is data science, but you would require statistics. I'll tell you how. And you will already, in the end of the 14 slides are there. So in the end of the 14 slide, you will automatically come to know, okay, this is why we use statistics, and this is where we use statistics. And yeah, it plays a great and very important role in data science. Okay, and for making any data science project. So yeah, without getting in much detail of the data science, because this is a statistics session. So yeah, let's jump onto that. So statistics, what statistics is basically, again, it is used to all kind of science and business applications. It give us more accurate knowledge, which help us better to make better decisions, right? Statistics can focus on making prediction about what will happen in the future. Okay, it can also focus on explaining how different things are connected. Okay, so all these things we can learn in statistics. So basically, it helps you make the predictions, or it can help you it can help you focusing on explaining things, right? So these are the things that we generally do using statistics, right? So yeah, then there are certain steps of statistical, like there are certain steps of statistics. First we have to start with gathering of the data, because in this step as well we have to gather the data, right? So you can take it for the data science pipeline, we have already done this step. So but in statistics again we have to do this step, you can take that, or if you have done that in the data science project, so you don't have to do that again. So first step in general is called gathering of the data. The second and very important step is describing and visualizing the data. So you have to describe the data. Let's say describing means what is the other statistical values or properties of that particular data, like what is the mean, what is the mode, and what is the median of the data. How many types of nan values or null values are there. Okay, how many types of other types of values are there, what are the properties of those values, total number of rows, how many rows are there, how many columns are there. So all these values, all these things comes into the describing of the data. And visualization, you know how data visualization is using matplotlib and cbon. Okay, so visualization again will also go in detail in the further slides, but just to give you an idea, the visualization can be done in uh, yeah it can be done in the form of plots, let's say histograms. Okay, or let's say some pie charts. It can be done in the form of pie charts as well. So these are the things of visualizing the data. Now the third step is making the conclusions. Okay, what we have concluded from the statistics while and applying from statistics on the data. So making the conclusions. So this is the third step. So first, second, and third, these are the three steps of uh, any statistical method. Cool, guys. Yeah. So yeah, let's move on. So we have already seen that typical steps of statistical methods. Yeah, we can move on to how is statistics used. Okay, so statistics can be used to explain things in a very precise way. Okay, and you can use it to understand and make conclusion that the group that you want to know more about. Okay, uh, this particular group, now comes the concept of population, right? So the group that you want to, let's say there is a group of people. Let's say you work in X company. Okay, in X company, you have certain types of people who know data science. Okay, you have to collect the people and you want to make a survey of the people who know data science. So I'm representing the people with X, small x. So these are the group of people that you want to, that know data science. Okay, so all these groups of people that you want to conduct the study or conduct the survey. Okay, these group of people are called population. Okay, these groups of people are called population. Okay, now a population could be many different kinds of group. Okay, it could be all the people of in a country, right? It can be divided on the country basis, like we already know this is a very general term. Or it can be all the businesses in the industry, right? So businesses in the industry. Or it can be customers of a business. It can be a group of customers. Or it can be people who are playing certain sports, let's say cricket or let's say football. It can be divided on the basis of that. So it's all about what are the group of people, what are the sets of people you want to conduct your study on. Okay, and so on and so forth, right? It just depends on what you want to know about that group of people. Okay, now gathering data, yeah, we'll see that. We'll see that in the next. So let's move on. So now coming to the gathering data part. So gathering data about the population will give you a sample. Gathering the data about a particular group will give you a sample. Okay, the sample is a part of the whole population, and the statistical method are then used on that this particular sample. So let's say we have the population as I explained you in the previous part, and this population, let's say all these people know data science. Okay, all these group of people have knowledge of data science, DS, right? But you want to select the people who belongs to, let's say, India. Okay, your company, your organization X with the name X, right? Your organization works in, let's say, US and India. Okay, and you have conducted the survey, and this is the result that you are getting. Like, these many people are there who know data science in your organization. Now you have to select only those people who are from India and know data science. Okay, so you have to prepare another sample, right? This is the complete population. Okay, you have to prepare a sample out of that. So let's say this is the sample that you are getting. Okay, these are the group of people that know data science, as well as they belongs to India. Okay, this is the data that you want. Okay, now this particular part of the population is called as sample. Cool, guys, this particular part is called sample. Now, the sample needs to be similar to the whole population of the SAM population, right? Of the whole population, basically. It should have the same characteristics of the population. That is, it should if the population have the data science and belongs to X company, right? Have the knowledge of data science and belongs to X country. So this particular sample, the people or the data in this particular sample should also have the knowledge of data science and should belong to the same company X, right? So the properties basically of the sample and the population should be same. The characteristics should be same. Okay, if you only include people, let's say with a particular name, okay, in this group, okay, uh, and the sample will not be very similar to the whole population. In that case, let's say you are selecting only specific people, okay, with this particular name. Okay, then the sample won't be very specific, meaning, let's say this people name starts with A, this people, or let's say some this people name is A, and this is the name of the people. Other people is B, this people has the name as C, this people has name A again, right? And if you are selecting a particular person with a particular name with a particular, but he is having age of 18, he is having age of 20, let's say, although a person with the 20 ages, he must not be working for an organization. But again, let's take an example for that matter. So in the sample, what you are saying is, now I select a different sample. This sample is S1. Now I'm selecting a different sample S2, and in this sample I'm taking this particular person whose name is A and whose age is 20, and he belongs to X organization, and he belongs to India as well. Okay, now this particular thing is not very, now these characteristics like age 20 and his name is A are not very similar to the population, you see, right? Because not many people must be having this particular name and at this particular age, right? So this particular characteristics that you are showing are not generally considered as a part of sample. Okay, we generally try to avoid those things. Now, so basically, a good representative sample is very crucial for statistical methods, right? And that's the thing that we always try to follow in our sample and population distribution. That's the thing that we always try to follow. Cool, guys. So that was gathering of the data. We can move on to describing of the data. Now, describing of the data is typically the second step of statistical analysis. Okay, that will come after the gathering of the data. Any doubts you have? Now, yeah, describing of the data. So describing of data comes after gathering of the data. Now, the type of statistics that we call in the describing of the data is called descriptive statistics, right? The information data from your sample or population can be visualized visualized using the graphs, okay, or can be summarized by numbers. Okay, so all those things your data can be used for. I changed the color. This color is very irritating on the screen. So yeah, can be represented using graphs and can be summarized using in tables or some numbers. So summarization can also be done. Guys, if you're raising your hand, so I'm in the middle of a topic. What you can do is you can just write your question in the chat, or I'll take your question in the end for sure. Okay, I'll not close the session without taking your doubt. Okay. Don't worry. So just hold on for let me deliver the content that I have, and definitely will take your doubts for that. Cool. Okay. Yeah. Hmm. Yeah, descriptive statistics. So this will show key information in a simpler way. That's the aim of a descriptive statistics, or describing of the data, to show the data in the form in a simpler way. Rather than just looking at a raw data, you can visualize the data using graphs and summarize by in the tables, or by the numbers. Okay, it can also help us to understand the data, how the data is distributed, right? It will help us to understand how the data is distributed. Like it is the data we have are, let's say we are having a survey between men and women. Okay, so it will, if I have plotted the data, okay, let's say in the form of pie charts. So this is a pie chart, and it shows something like this: the more number of men are there and less number of women are there who has taken the survey. Okay, so it will definitely, the data is itself uh, saying that the number of men has taken more surveys and the woman has taken less survey. Okay, so the data is very descriptive in itself, and which help us to understand how the data is. So if we are taking the survey for any product, let's say, and the product is mostly used by the women, right? It's mostly used by the women, so we won't rely on that particular data, because we know that the survey was taken by men. Mostly men have taken the survey rather than women, so we won't rely on that particular data, right? So that's the thing, that are the insights that we get from the data. So there are different roles in the industry, right? There are business analysts, there are data scientists, there are what to say, machine learning engineers, there are data engineers, right? So everyone has its own role, but the business analyst team is what they work on these graphs, they work on Tableau, they work on Power BI. So all those things they work on, they try to visualize the data and will try to extract the insights for the business team, right? And once the visualization part is done and data has been already pre-processed, so now it is sent to the data science team, or data scientist group of data scientists, who will write the algorithm, or will go with the models part, right? So that is the procedure in the industry, but it's a topic of discussion of some other day. Okay, now different types of graphs. Let's go into the details of what are the different types of graph. So you have something called histograms. Okay, then we can have pie charts, then we have bar graphs, then we have box plots. I'll tell you a few important points about box plots. So box plot, if you know that box plots are very good source of finding the outliers. In case you want to find the outliers, the box plot are one of the best plots to go with that. Okay, so that is one thing. Now, some graphs have a close connection to numerical summary statistics, and calculating those give us the basics of these graphs, right? Let's for box plot, there are terms called quartiles. Okay, the box plots are divided into quartiles. So this is how some box plot looks like. This is how a box plot look like, and these points, let's say there are points out like this. So these points are called outliers. So outliers are again calculated by some formula between IQR and Q1 and Q2, different quartiles. It comes out with some formula, and that is how the outliers are also calculated. So it's a topic of discussion for some other day, because it would take complete 1 hour to calculate the outliers and explain you what outliers means. Yeah. Okay. So there is another concept which we call as summary statistics in this summarize part. Okay, now in order to summary statistics, summarizing of the data is a part of summary statistics. It basically, we take a large amount of information and sums up with few key values, right? There would be some key values that will sum up the complete data we have, right? Now, numbers are calculated from data, which also describe the shape of the distribution, right? Some important examples that we use in summary statistics are, let's say, mean, our median, our mode. Okay, or we calculate range, we calculate percentiles. Okay, we calculate quartiles. Okay, we calculate standard deviation and variance. So all those things are a part of some summary statistics. Cool, guys. So yeah, that was I think more than enough for describing the data and descriptive statistics. Okay. Now, generally there are two types of statistics, guys. One is descriptive statistics, other is inferential statistics. Okay. So we'll take that in the coming slide as well. So yeah, let's move on. So now this now comes a statistical inference. So descriptive statistics we have seen in slide number 6. Now in slide number 7, we are covering the statistical inference or inference. Yeah. So using statistics to make conclusion about a population is what we call as statistical inference. So in here what we do is we make conclusions. What type of conclusions? Now the conclusion can be of any type. Like let's say you want to make a conclusion of whether this particular vaccine, whether you have taken a population of data and you have tested the vaccines on that data. Okay, you have tested the vaccine of some disease, right? So you have to make a conclusion whether this vaccine is appropriate for this population or not. Okay, so generally what we do is we take a sample out of this data. Okay, this is called sample, and we test the vaccine on that this particular sample, not on the complete population. For example, if I tell you a real life example, so if you have seen and if you were involved in the time of COVID, uh, not involved like involved as in through media and stuff, and you have been reading that stuff. So you have seen there was a drive which invites the people to for the vaccine testing, right? So Indian government has taken a group of a sample. Okay, every time whenever a vaccine is being tested, the government or the organization take a sample of the people on which people on the set of the people which on which the vaccines would be tested, right? They don't test it on the complete population because it will again have multiple consequences, right? Because for a country, people are the backbone for economy, for agriculture, for everything. People are what makes the country. So they take a small sample of the people and they test the vaccine on that people. Now the sample must come from different area, different backgrounds, social or economical backgrounds. It should come from different parts of the region. It comes from, like, one come from east, west, north, south, all these regions. The sample should have contained, right? So such type of sample is very good, which has the variations in all those things. Now which will bring us to my next topic. In after a few slides I have a topic called uh, that is called sampling, how the sampling of the data is taken. It's not always what we used to think is the samples are taken as randomly. Like sometimes I pick this people, then I pick this, then I pick this, then I pick this person. So this is not how a sample is taken. It may be taken like this, but there are again three four ways of taking a sample. Okay, not only the random way. Random is one of the way, but not the only way of taking the samples, right? So again, what all things depend on it, like how the samples are taken, we will see that. But in short, the taking of the sample depends upon the problem statement, depends upon the conclusion we want to make. Let's say if I want to make the conclusion on the people who are living in snow, or let's say in very high altitude, right? So I have to take the sample from that particular area. I can't take the sample randomly from the whole country. I have to take the sample from that particular area, let's say Jammu Kashmir, or let's say people who are living near Himalayan region, right? So again, that's the thing. So yeah, coming back to statistical inference, so it is used to make conclusions. Nice, right? Now, statistics from the data is a sample. In the sample is used to make the conclusion about the whole population. Once you have got some conclusion for the sample, we'll apply those conclusion to the whole population itself, right? Just like the vaccine, right? You have the vaccine comes out to be okay for the sample, right? So then you will apply it on the whole population, right? Just like it at the time of COVID, it was it, because the sample was on the sample, it is giving some, let's say for example, it is giving 98% accuracy. Now the organization is thinking of to apply it on the whole population, and let's relieve the people with that. So yeah, this can be done, right? Now there are few important concept, let's say a few important concept that comes into the while studying statistical inference. One is probability theory, or probability simply. Okay. The other is hypothesis testing. right? So other is confidence level that we call as CI, right? So all these things comes into the picture when we work on statistical inference. Cool, guys. So let's move on to the next part. Yeah, prediction and explanation. This is a pretty small one because prediction, some statistical methods are not focused on explaining how things are connected. They are only focused on the accuracy of the prediction, right? That is what it is important for you, for them. Like now the uh, some statistical method might focus on prediction, some focus on explanation of how the data is distributed. Okay, how the data is distributed, how the data is connected, and all that stuff it may be related to, right? But some algorithms or some statistical methods are related to over prediction, like prediction of the, let's say, uh, what is the stock price, for example, I'm talking about, and whether this some kind of prediction that we do in data science. So all those prediction, uh, these statistical methods are based on, right? Let's say number of men would be there in more in that particular region or not. Okay, let's say we have conducted a survey, okay, where we have seen the age of men and women, the average age, the average lifespan of men and women. Okay, and the data comes out to be that there is a trend of when where the men increasing trend in the case of men, like the number of men are increasing, the lifespan of the men are increasing, and the lifespan of the women are either decreasing or it's almost constant, right? So this type of analysis can help us to make a prediction that in that particular area number of men would be more after a few years. Okay, so again, that's a type of study, and that's a type of prediction methods that we use. Okay, and then comes this explanation statistics or methods, right? There we introduce some term called as causal inference as well. So yeah, that's the thing. Will not go in much detail of that. Yeah. So I think we have already covered what is population and what is samples, right? So population, if one liner definition I want to give. So population is everything in the group that we want to learn about, and sample is a part of the population. So population is ultimately everything that you want to learn about, and sample is a part of population. Sample is basically a part of population. Now, right now the population, if I want to differentiate between them, so the population is, let's take an example of people of the all the people of a country. Let's say all the people of India. Okay, and the sample may be 500 people. Okay, population may be all the consumers on Netflix, and sample may be 300 consumers on Netflix or something like that. It's just that the representative sample should be good, like the sample should be good and should match the characteristics or features of the whole population. So yeah, let's move on then. Parameters and statistics. The term parameter and sample statistic refers to the key concepts that are closely related in statistics, right? So the parameter is basically a set of number that describes something about about the whole population. Like parameters maybe they belong to a particular region of North India, right? Out of whole population, like since this is a population, let's say. Okay, now this population can have parameters, right? We have seen that this example as well, but let's take it again. So what was the parameters for that population? That all of them belongs to a X organization, right? uh, so that is the parameter that we have, right? So the parameters can be mean, median, mode, variance, standard deviation. Okay, so all these can be the parameters, right? So someday we'll study more in detail if we get time. Yeah, so what are the study types? Now let's see that what are the study types of study that goes into statistics. So generally the study types are divided into two types. First is observational. Sorry for the writing, guys. Observation. The second is experimental. That's some perks of being an engineer. So observational or experimental. Now we often interested in knowing if something is the cause of another thing, right? So experimental, that in the experimental study, the circumstances around the sample is changed, right? Usually we compare two groups of a population, and these two groups are treated differently, right? So again, experimental is what we have done experimental studies on, and observation is, the terms are very self-explanatory, so I won't go in that detail for that. Now, let's jump on to the sample types. So a study needs participants, and there are different ways of gathering them, right? Some methods are different from others, but they might be more difficult, right? So we have seen, I told you that there are many sampling types. So let's try to understand few of them. So I'll name all of them. So first is random sampling, that we generally see and that we generally know that this must be the sampling technique that might be used. So first is random sampling. Second one is convenience sampling. Convenience sampling. The third one is, let's say, systematic sampling. The fourth one maybe stratified sampling. The fifth one maybe clustered sampling. Right. So these are the few types of sampling. In case of random sampling, the equal number of population has equal chances to be chosen, and you can choose the random samples randomly, right? In case of convenience sampling, where the participants that are the easiest to reach are chosen, right? So the participants are when it's easier to choose. That's why the name is convenience sampling. In systematic sampling, the participants are or the samples are chosen by some regular system. Okay. For example, the first 30 people in a queue, okay, or every third person on a list, okay, or the first 10 and the last 10 persons, okay, something like that is done in the systematic sampling. Now, stratified sampling is where the population is split into smaller groups that are called strata, that are called stratas. And the strata, for example, can be based on demographics like different age group, different professions, people who are knowing data science or who are not knowing data science. Okay, so all that stuff comes into the concept of stratified sampling. In case of cluster sampling, it's very self-explanatory term, but again, is where the population is split into small groups, but in this time they are called clusters, as expected, and the clusters are then randomly chosen for the sample. So it's not like that if we only start with one sampling and we do all the process. Okay, we can have a combination of random sampling and convenience sampling. Like in case of clusters, let's say you have making small clusters. Now how the clusters are chosen and how the data for a particular cluster is chosen, then you can go with either random sampling, or you can go with convenience sampling, or let's say systematic sampling. Like first 10 people, you are making a group of first 10 people, you are making cluster of first 10 people. This you can do, then it will be called as clustered systematic sampling. So a combination of sampling can also be used to get the data or to get the sample, basically. Cool, guys. I hope that was clear. Now coming on to the next part would be, I think, data types. Yeah, data types. And now the data can be of different types, as we have already seen, and it requires different types of statistical methods to analyze, right? Few types. So we generally divide the data into two types. First is you might be knowing that qualitative data, and the second one is quantitative data. Now, a qualitative data is information about something that can be stored into different categories, and that can't be described directly by numbers. Okay, for example, let's say brands, nationality, profession, all that stuff can be comes under qualitative data. And quantitative data, it's very clear that information about something that is described in the form of numbers. Let's say income, let's say age, let's say height. So all these things comes under the quantitative data. Cool, guys. Now I think we'll come on to the last part of the session, that is measurement levels. So different types of data have different type of measurements levels. Okay, measurement levels are important for what type of statistics can be used, uh, can be calculated, and how the best presents the data, right? So nominal level, ordinal level, and interval level. ratio level. These are the 4 types of level that we have in measurement levels as measurement levels. Okay. Now I would open the stage for you all. You have I'll see the doubts that you have and we'll try to resolve them. So if you have any doubts, you can write in the chat and we'll try to resolve that.
Abhishek, before we go on, I'd like to add, please, to the attendees, please put your questions in the Q&A window. And also, we're throwing up another poll, so please do keep that in mind as well. Please attend the feedback poll as well. Okay, thank you.
Yeah. Okay, so calculus and linear algebra. Okay, Akshay.
Excuse me, Abhishek, could you also please read out the questions before you answer them? Okay.
Okay, cool. Yeah. Can we verify that a sample truly represents the population? Yeah, we can verify by comparing the characteristics or properties or parameters of both the sample as well as the population. So yeah, we can do that. So how do you compare two data sets from two different populations in two different locations? Again, it depends upon the question you have, the problem statement you are going to solve. So there you can use that in terms of statistics. You can use statistical methods like mean, mode, median, and you can plot some graphs out around that so that you can compare those two things. Right. So yeah, it depends upon the problem statement, but from the statistics side, if you want the answer, then you can use the different statistical method: mean, mode, median, standard deviation, variation, percentile, quartiles. All these things you can use. When to use which plot? Okay. So this is very good question, and I generally receive these questions when I go into the details of matplot and Seaborn. And I always expect that question to be asked because I have also asked such type of question, and honestly there is no very strong answer I have, and nobody will generally have the answer for that, because the reason being it's all about the experience and the data that you are having. For example, yeah, so again it depends upon if you are plotting the some data you have, right? If you are plotting it in the form of pie charts, okay, then it might be better if you plot as a bar graphs. Okay, so again it depends upon how you visualize it, what is your problem statement, what you want to solve through that data, what you want to extract from the data, what information, what result, what conclusion you want to make. So also it's not like I am doing a data science problem and suddenly it comes into my mind, okay, let's apply pie charts. Okay, let's apply the bar plots. Let's apply histograms. It's not like that. I have to try on every instant. I have to first, I'll plot the histograms. Then I will understand, okay, this will not make sense because I want the data I want the data in the form of pie charts. Okay, then I'll go for pie chart. Okay, then I'll understand, okay, the pie chart is not also working. So let's go with bar plots. So eventually after making 2, 3 or 4 projects, you will eventually understand and develop that intuition of selecting the plots, right? And selecting the right plot in at the first instant. So Akshay, that's the thing. You will develop those things. How we build the data model? That is $1 million question, and that would be answered in, let's say, some another session. We'll take another session on that, how to build a data model. But talking about the models, you have to choose the model on the basis of the data and the conclusion you have to make. That is what I can tell you at this point. Again, it depends upon the data. If it is a regression problem, regression algorithm would be chosen. If it is a let's say prediction model, or it is the data is more of a time series, you have to go with the time series model. And let's say ARIMA, AR model, MA model. So all those things you have to go with. So again, it depends upon the data you have. Different types of data, we can see that. Is summary statistics same as inferential? No, I guess. Yeah. No, they both are different in some cases. Outliers may be genuine. Yeah. Now talking about the outliers, sometimes it is good to have outliers because it maintains some noise in your data, and it will stop your data from overfitting. Okay, and you will have some noise in the data. So when you test your data, on some unknown sample. So having an outlier might be good, but again, it depends upon the use case you are doing. For testing a vaccine, you won't take a risk of having an outlier and testing and not having the data and not testing on the outlier, right? So you have to take outlier into the consideration, because also they are the type of the people, right? And in out of the whole population, there might be some people who belongs to the outlier category, and I think you should not be able to you should consider them as well. Okay, I think guys, you have my LinkedIn ID, so I think there are too many questions, and I have a other meeting to catch at 8. So we can do is you can ask me in the LinkedIn page on you can I am pretty active on the LinkedIn. I'll reply you as at the earliest, and yeah, you can ask me on LinkedIn because there are too many questions. I can see more than 50 questions I have. Thank you everyone. You have been a great audience.